Hello, in this video we will be showing how MO71 can show you the route a message takes through your network. Since version 6, IBM MQ has had a feature called Trace Route Message. The way this works is that as a special message, known as a trace route message, travels through the MQ network, MQ will send report messages back to the original sender. These report messages tell the initial application what happened to the message. For example, was it got from a queue or sent down a channel, etc. The sending application can piece together this information to determine what happened to the message. One of the key aspects of a trace route message is that it is never put to the application queue. Clearly putting it to an application queue could cause the application problems, so the message is discarded once it arrives at the target. To demonstrate trace messages, we shall just have a simple cluster along these lines. Here you can see that the 4 queue managers are in a cluster, and there is a cluster queue called CQ1 on 3 of the queue managers. IBM MQ comes with a utility which will generate a trace route message and display the report messages. It is called DSPMQRTE. The command to send a message is fairly straightforward. Here we are connecting to queue manager north and sending a message to queue CQ1. We can see that the response from DSPMQRT shows that the message went to east. If we issue the command again, we can see that the message now went to west. Each time we issue the command, we see that the message goes to a different queue manager. This shows that the normal MQ cluster round-robin algorithm is in effect, where each time you send a message, it gets sent to the next available queue manager. If you really want to see the whole contents of the trace message, then you can use the -v_all parameter. This will print the whole of the trace message, which could be really useful for working out exactly what happened, but it is clearly not easy to parse. However, as you can see, there is a lot of information here, which may be very useful for diagnosing a problem. So let's now see how MO71 would trace the same situation. First, we bring up the trace message dialog and ensure that the source queue manager and target queue values are set. If we now press the send button, we can see that MO71 shows us what happened to the message. If we press send again, we can see that, as before, each message is sent to a different queue manager. MO71 constructs this diagram from the trace route message contents. If you want to see the raw data, then you can do so by choosing the raw display type. This will show the contents of each trace route message in a formatted display. However, most of the time the diagram display contains what you're interested in knowing, and it's far easier to understand. Of course, one of the things you may be interested in knowing, especially in an MQ cluster, is the distribution of messages. What percentage of the total messages is sent to each destination? To show this, MO71 allows you to show the distribution as a pie chart. We can see that each time we press send, the pie chart changes. Clearly pressing send multiple times is not ideal, so if you're interested in a distribution, then it is simpler to increase the message count. To demonstrate this, let's start again by deleting all the current data and sending multiple messages, but this time setting the message count before we press the send button. We can see that lots of messages are sent, but the pie chart painting is rather jerky. This is because trickle feed is checked. Let's try that again without trickle feed. Again, we shall delete the current data before we press the send button. You can see that this is a lot faster. So what is the point of trickle feed? Well, one of the other things that MO71 can show you is how long the report messages take to make the round trip. We can show this by adding response times to the diagram. We can see that MO71 shows the minimum, maximum, last and average response times to the target systems. Of course, the measured response time is hugely dependent on what else the system is doing. In order to get the most accurate response time, therefore, we want to minimize what else the system is doing. To achieve this, instead of sending all 12 messages at the same time, we want to trickle feed the messages in so MQ is only trying to process one message at a time. If we look at the response times when we trickle feed the messages, we will see that the response times are shorter. Of course, if your system is live and processing lots of application messages anyway, then you may not see such a difference. The key thing about response times is that they are variable and will be dependent on the current workload of any machines and channels involved. However, displaying response times in this fashion can be a great way of looking to see where bottlenecks may be in your system. So far, the example we've shown is a single cluster. Let's show some other examples. The simplest case, of course, would be putting to a local queue. Perhaps the next simplest would be putting to an alias. Remembering, of course, that the message never actually gets put to the local queue. Now let's target a cluster queue, but this time the queue exists on 6 different queue managers. You can see that the diagram will happily show as many targets as you wish. Notice also that in this case we are using the split cluster transmission queue, where each queue manager used has a different transmission queue. This next example shows that you can have embedded clusters where the cluster routing decision happens multiple times. Of course, usually it is much simpler than this, and you just want to check where a remote queue definition goes. That concludes our quick demonstration of trace message, and I hope you found that useful. You can see that traceroute gives you 3 good bits of information: the route a message takes, the response time of the various targets, and the distribution pattern. If you have any questions or comments, we'd love to hear from you. Thank you.